Ever find yourself just totally lost in a chaotic, messy process? You know the exact feeling. You're staring at this massive wall of text, or maybe a super disorganized standard operating procedure, and you have absolutely no idea what step comes next. It's frustrating, it completely drains your energy, and honestly, it just leads to mistakes. But there is a cure for all that chaos, and it's actually been around for decades. I'm talking about flowcharts, the absolute ultimate tool to organize logic.
Okay, let's dive into this explainer. Because whether you're mapping out a complex software architecture, a business workflow, or literally just a daily chore, understanding how to properly read, build, and deploy flowcharts is practically a superpower for clarity.
Think of this as the flowchart for today's explainer. We're going to decode the basic language of shapes, check out the essential structures, walk through 5 steps to build your own, hit on some common mistakes, and finally, we'll navigate the modern tool ecosystem. All right, starting with Section 1, Decoding the Flowchart. Let's look at the universal language of shapes.
To really ground this, let's look at a fascinating real-world example from our sources, a dairy farm's standard operating procedure for dealing with cows with abnormal milk. First up, the flattened oval. In this universal language, this shape always represents a starting or ending point. So in our dairy farm example, this is the exact moment the milker detects that something is wrong, which kicks off the whole diagnostic procedure. It just immediately tells the reader, hey, start right here.
Now, once you start, you usually need to actually do something, right? And that brings us to the rectangle. This indicates that a specific action needs to be performed. Continuing with that farm SOP, an action rectangle might tell the worker to milk the cow according to procedure, but divert the milk into a waste pail. It's a crystal clear, indisputable instruction. There's no ambiguity, just a defined task to go execute.
But processes aren't always a straight line. Enter the diamond. This is the universally accepted symbol for a decision point. It's basically asking a question. For instance, is mastitis present? From this diamond, you have to have at least 2 arrows leading away toward different alternatives, usually a yes and a no. This shape is the exact moment where your process branches based on real-world conditions.
Moving right along to Section 2, Essential Symbols and Structures, where we actually start building the logic.
So literally any complex system can be broken down into 3 basic structures. First, you have the sequential structure, where steps just flow in a linear path from top to bottom. Second, the selection structure. This is where those decision diamonds come into play, branching the flow based on your if-else conditions. And finally, the loop. This is brilliantly represented by a decision box with an arrow that points all the way back up to an earlier step. It just repeats a block of actions until a specific condition is finally met. Master these 3, and you can map out pretty much anything.
So how do we put all this theory into practice? Let's transition into Section 3, Steps to Build Your Own, moving from chaos to clarity.
Our sources highlight a really satisfying 5-step creation process from Miro, and it brilliantly illustrates a structured approach. Step 1, determine the purpose and scope. Don't just start drawing. Know exactly what you're wrapping first. Step 2, identify the steps and get them in sequence. Step 3, choose the appropriate symbols. Remember, rectangles for actions, diamonds for decisions. Step 4, draw the connection arrows to dictate the actual flow. And Step 5, test and improve. Run a hypothetical scenario through your chart and see if it breaks. And if it does, well, refine it.
But hey, even with a great process, things can definitely still go sideways. Welcome to Section 4, Common Mistakes to Avoid, and the traps you really need to watch out for.
Mistake number 1, overcomplicating the flowchart. Remember, the entire point of this exercise is to simplify a complex system, not to recreate all that complexity on a screen. If your chart turns into a tangled web of hundreds of crossing lines, you've completely lost the reader. You got to keep it simple, keep it modular, and just break massive processes down into smaller, linked subcharts if you have to. Then there's mistake number 2, using inconsistent symbols. I know it can be super tempting to invent your own custom shapes or creatively color code things based on your mood, but don't do it. Stick to the universal standards. The second you use a diamond for an action or a rectangle for a decision, you break the visual language we just talked about, and you instantly confuse anyone else who's trying to read your document.
And mistake number 3, this is a big one, missing decision points or failing to label your arrows. If a reader hits a diamond and the arrows coming out of it aren't clearly labeled yes and no, they are trapped. The logical sequence is just entirely broken. Every single step and every single connecting line has to be explicitly clear.
Now that we know how to build a flawless flowchart, where exactly should we build it?
Let's move into Section 5, choosing the right tool in the modern diagramming ecosystem.
Our sources break down 3 absolute heavyweights in the modern software landscape, and they actually serve very different purposes. Draw.io is free, highly technical, and outputs in an open XML format. It's basically an engineer's dream. Lucidchart is a paid software focused heavily on real-time, cross-functional collaboration, which is perfect for corporate teams editing together live. And Miro, well, it's a digital whiteboard. It's meant for free-form brainstorming and slapping sticky notes on an infinite canvas. So, choosing the right tool depends entirely on whether you're documenting strict architecture, collaborating on a process, or just brainstorming raw ideas.
Now, what's really interesting here is this crucial point about file portability. If you use a tool with a proprietary format, your diagrams are locked into that specific paid ecosystem. If they raise their prices, you're pretty much stuck. But tools like Draw.io use open source XML. That means your flowchart is actually just a plain text file under the hood. It's completely portable, it easily survives tool migrations, and for the developers out there, it's Git-friendly. You can track exactly who changed what line of logic in a pull request, which is huge.
But what if you don't even want to drag and drop shapes at all? Enter Mermaid.js. This is a completely different approach that's gaining massive popularity right now. Instead of manually trying to align rectangles and diamonds with your mouse, Mermaid allows you to literally script your diagrams using code.
With Mermaid.js, you just type graph.td to say, hey, make this top-down. Then you type A with the word start in brackets to create an action box, draw an arrow using some dashes, and point it to B with the word decision in curly braces to create your diamond. The library automatically renders the shapes, draws the arrows, and perfectly aligns everything for you. It is just incredibly efficient if you want to keep your hands on the keyboard and treat your diagrams as version-controlled code.
And finally, we are stepping right into the future with AI diagram generation. Tools like diagrams.so allow you to just type out a plain text description of your system. And the AI doesn't just generate native portable XML that you can open anywhere, it actually checks your logic for architectural warnings while it builds. It completely eliminates that dreaded blank canvas paralysis.
So, we've covered the shapes, the logic, the pitfalls, and the really incredible modern tools at our disposal today. Flowcharts are definitely no longer just static, boring corporate documents. They are dynamic, code-driven, and even AI-assisted engines of clarity. So I want to leave you with this question to ponder. When it's time to map out your next big project and bring order to the chaos, will you be dragging shapes, writing code, or simply asking AI to do it for you? Thanks so much for joining me on this explainer, and I'll catch you in the next one.